Alright, hello everybody. Welcome back. It's Alex again, lesson 4 this time, charge magnitude and conservation of charge. So basically we're going to talk about 3 specific topics. I actually didn't put this in here, but we're talking about charge magnitude. Charge is quantized, and I'll explain what that means, and the conservation of charge. So first, charge magnitude. This right here, we mentioned it in lesson 3, but you're going to see this a lot. But a charge of an electron is represented by the letter E right here, and it has a charge of 1.6 E negative 19 coulombs. If you want to be really technical, it's a negative number, and that of a proton is the same magnitude, 1.6 E negative 19 coulombs. So you're going to see people perhaps doing these like 8E, 6E, multiples of the charge. Now, what does charge is quantized mean? So this right here, this little equation right here, oh, and note, you should probably memorize this number. It would be very useful, but once again, from my experience, the professors are just going to put this number on your sheet and you should be fine. But if you remember it, then great for you. You don't have to flip all the way back on a test. So this equation right here shows that you can only have one electron, right? Electron can't be broken up anymore. It's a fundamental particle. So this n right here is number of electrons, right? And then E is obviously the elementary charge. That's what it's called, the charge of an electron. And Q is just the charge of the object or thing. And so you can find out what, how many electrons are there in a specific object. And if you end up getting a decimal number for n, most likely you're going to round for that, because you can only have a whole number of electrons. You can't have half an electron. So there's only a certain numeric value of charge that you can have, because electrons are quantized like integer numbers. There is 1 electron, 2 electrons, 3 million electrons, etc. So here's a little practice problem right here. So we want to know how many electrons are there in this much charge. So basically what you're going to do is just do Q equals NE, and you're going to find the number of electrons. So you're just going to manipulate the formula, N equals Q over E. And that's just 1.28 E negative 18 coulombs over 1.6 E negative 19 coulombs. And if I made this problem correctly, that's just 8 electrons. So 8 electrons, right? So the higher the higher the magnitude of charge, the more electrons you're going to see. And so if you see something that is 3 millicoulombs, you're going to know there's a ton of electrons in there, versus 3 nano coulombs, right? And the last thing I wanted to talk about was that the conservation of charge. I'd originally put this in the lesson plan for today, but we kind of went over it with the shells in last lesson. So basically, charge can't be created when the two objects touch each other. They're going to share the charge in a closed system. If there's any facet for them to get out, within that system, the number of electrons are still going to be there. So that's basically it. Super short lesson. We're going to move on to chapter 2, electric fields, in next video.